Welcome to our channel. Hi there, my name is Ranjan. I am a full stack DevOps engineer with 11.5 years of experience working in IT. I am also a 4.5 star rated Udemy instructor teaching more than 72,000 students worldwide. On this channel, my goal is to make you learn and grow by sharing my experience. So if you like my work, then do like this video, share it with your friends, and don't forget to subscribe this channel for more such awesome videos in future. So let's get started. Thank you. Alright, let's start with the next topic. It is called predicates. So let's create a package. Predicate. Predicates. And now what we will do is here let's look at a little bit about what are predicates. So I will say E and predicates. So as you know that we have learned about functional interface. So predicates are predefined functional interfaces which are provided by Java. So we have seen how we can create our own functional interface, but Java also provides some predefined functional interfaces called as predicates. So these predicates predefined functional interfaces return Boolean value. Boolean value is the return type of this kind of predefined functional interface. So let's try to create an interface here as predicate. And this interface will have, let's say, a public Boolean test function, test, and then it can take any kind of data type. So I will say T. And here we can say this is of type T. Now this you can declare it as a functional interface at rate, I would say functional interface. Now let's say if I wanted to do some logic here and there, then I would basically do an implementing class and do those kind of things. Let's do that. So let's say predicate demo. I will put it this way. So let's say very simplistically, if I want to just let's say it implements the predicate interface. Okay, now we have to add the implementation. Great. So now what will happen if I have to give a logic here? So let's say if I have to use this, I will pass integer. Then I will say integer. And now here, if let's say if let's give it as name as age is greater than 18, then we would say let's say return true, else whatever of the other part is return false. We can put this one inside else, that is fine. Okay, and then we of course we will create a predicate demo main method class predicate demo main. So this is how we used to do it Java 7 till now. So public, I would say static void main string array args string array, and then I will say how do you test it? You can basically you will say predicate equal to new predicate impl. So it's not predicate impl, it's basically predicate demo, and I think we have an extra bracket here, that's fine. And then you basically say predicate dot test, and let's say pass 20. So you can say boolean result equal to, you can say something, and then you can say system dot out dot println, and then you can print result. So if you run this program, you will see the result as true because 20 is greater than 18. Okay, but now we have done so much already. How would you do this using Java 8? So using Java 8, it will be very simple. So we don't have to declare this predicate interface at all, nor we need a class to implement it, nor a demo main class. Yeah, basically we need the demo main class. So let me draw this again. I mean create it again. I will say predicate demo, predicate demo main, but this time Java 8. So here this is just a normal class, and it will have its have our main method. And now what I'm going to do is I'm just going to call predicate, but not what we had. If you see, Java already provides. So what we said, predicates are predefined, pre-provided functional interfaces of Java. So predicate, let's say I want to do the exact same program again. So I will say integer, and I will say result. So what we need to do? First, let's go into this interface, predicate interface, which is provided by Java. So it has one abstract method, which is Boolean, that we know. Okay. Then there are some default methods. Add, which is taking some parameter. Another Boolean, another default method, negate, or then it has a static method as well, is equal. So actually the predefined predicate functional interface, which is provided by Java 8, has one abstract method and some default methods and one static method. So now we want to directly use it. So I will say result, and now we want to convert this. We want to convert this into a lambda expression. So you know how to do that. We will ignore the return type. We will ignore the method name. We will just have the parameter. And as it is a single parameter, we will also ignore this bracket and the data type of the parameter. And then we will just have the logic. So here, no return type, no method name. So we will start with this. And the parameter will be integer because this is what we are passing here. So let's say integer age. And then we will say bracket. We will say return age is greater than 18. Let's put it this way. And then we can say system.out.println result. So let's run this one. But now you can call result, but we need to call the method. We need to call the method. So how we will call the method? We will say result.test. Test. We will call the test predicate method. So this is an interface. So we'll say let's rename it predicate, and then we'll say predicate dot test, and now we will pass, let's say here 20. So as soon as we pass this 20, it is going to go inside this method, which is the implementation here, and it is going to execute the code, and then it will return true. So it returned true. Great. Because this is, as I said, let's copy this. We have already seen it earlier also, but I'm going to put it here again. Because this is a single argument, so we don't need this. We don't even need this. We don't even need this. This can also go away. This can also go away. Even the return can also go away. So now this is going to exactly work like this line. So we are able to reduce such a big thing that we do here, we implemented here with the help of a main method and an interface by using just one line. That's the power of predicate. So predicate helps us evaluate an expression. See, so this here it is evaluating. This is the predicate interface, which is a function interface, has a test method, which is helping us to evaluate whether something is greater than or less than the conditional basis, and it returns true or false. So if I run this, it's providing the exact same result. So this is what predicate can do. So let's check another example to check whether an array list is empty or not. So I will say array list of, let's say, string. So I will say names equal to new array list. So this is my array list. Okay. Now I want to check if this array list is empty or not. So what I will do, I will create predicate. No, I want to create the predicate only. So predicate of this and of array list, because this is what I want. So I will say predicate 1 equal to, now I have to say what is the item. So item is, because if you remember, I have to go and again do this. I will have to write the lambda for this. So I will say array list A, or I can say list. Then I can say I have to check, I have to do like this, return list dot is empty. But because this is again a single line, I can replace this whole thing with, I mean, as this is just a single parameter, so I can get rid of this bracket and this not required, and this is also not required. So this will work as like this. So what I will do now, I will say system.out.println, I will say predicate1.test, and then I will pass this names. So now the names, let's run. So the names should be empty. because there is nothing in this. There is nothing in this array list, so it should be empty. So it will return true. Let's run it. So it is true. So now let me go ahead, and after this line, I will say names dot add. I will add John, and now I will again do this one, predicate dot test. This time it will be false because it's not empty anymore. So great. So this is how we can also test the emptiness of an collection using predicate. All right. Let's write down to check whether a particular number is odd or even. Let's check it with the help of again predicate. So predicate examples. Let's say I will put it this way. So more examples of predicates. So I need the main method. So I'll copy it from here. And let's see predicate. Let's create. Let's say if it is let's integer again, and then say odd, even. Let's do this way. And then what I will do is I will directly say the number. Let's say number, because it's again single parameter, so everything can be skipped. And then I will say num modulo 2 equal to 0. Let me say is odd. So now I will say system dot out dot println, and I will say is odd dot test. I will pass here. Let's say 4. So 4 modulo this not equal to 0, so it will be false. It's not odd, so this will be false. If I pass 7, this will be true. So you can write an odd even check method with just a simple logic here itself. Now let's do one thing. Let's create an array. Let's create an array. I will say integer array of numbers, and then I will just say 2, 6, 9, 4, 5, 8, 22, 19. Okay, let's let it be this much. Now what I will do is I will basically apply a for loop here. So I will say for, I will say integer num, and then I will say numbers. What I want to do is I want to first print all the odd numbers. So I will say odd even predicate. Let me rename it. So it odd even predicate. So what I will do, if I will say this is for odd. So if predicate dot test, I will pass this num. If this is then I will say system dot out dot print, not use print. I will just use print odd number, and then I will say okay, or let me put ln also, ln. And if this is odd, then it will print odd. Great. So what will happen now? Every number will pass. So 2 will be passed. So not equal to 0, so it won't be printed. This will not be printed. So we will see 9 and 19. So let's see. So odd number 9 and 19. Now I want to print the even numbers. So you will say, okay, make this one as equal to, then you can run it. Then it will print the even number. But what it is printing the even numbers. But what if I don't want to touch this logic? And now if I want to run it, then I will say, copy this. Then we will use the default method, which was, so I will say even number. And here, if you remember inside the predicate, there is an, not this one. So this is a predicate which we are using. Let's close all this one, which is creating confusion. So go to predicate example. So now we need to use the predicate, this one. So this is not the right predicate that we are using. So basically we should use the predicate, this one from the util function, java.util function. And now it was, because earlier it was taking our predicate with the interface that we wrote. So now if I go inside this predicate, which is Java provided, so we are using this. But if you remember, I said we also have a negate function. So let's see how we can use this. It's a default function, so it is already available in this field. So I can say dot negate dot test. So whatever will be returned from here. So let's say it will be, this number is 2. So here it will return, let's say 2 equal to, not equal to the modulo is not equal to 0. So it will return false. So it won't come here, but here it will make it as true. So it will be printed as even number. So let's run it. So that's the power of negate function. So even number 2, 6, then odd number 9, even number 4, 8, 22, then odd number 19. So you saw how we could use predicate Java provided predefined functional interface and do odd even very simply in just one line, only in one line. All right, now let's say, now what I want is, I want find all the odd numbers which are greater than 10. So here I will just say, let me say more odd numbers, 23. I will say 11. I will say 5. So if we run this program, we will see. So we have 9 odd number, 19, 23. So what we want is odd number greater than 10. So we should get 11, 23 and 19. How can we achieve that? So we have one predicate, odd even. So let's go ahead and create another predicate. So I will say predicate java.util function, and then I will say integer, and I will say greater than 10. And here I'm just going to say let's say number greater than, and I will say number greater than 10. So now we have to basically combine. So I will just say here, I will copy this, So here we have 1. So what I will say, greater than 10, this is one predicate. Let me put it here, predicate also, that will be easier. So I will say greater than 10 predicate dot and I will combine, and then dot I will combine the 1. So here I will say greater than 10 and I will pass this num. Let's 1 second, let this syntax incorrect. So what you have to do, greater than 10 predicate, along with that use this odd even predicate and then evaluate it. So now if we print this, so this here it should give odd number greater than 10. Let's run it. So this way you can combine two predicates, predicate 1 and predicate 2. So we see it prints odd number greater than 10. So let me put it here like this. So 11, 19, 23. Those are the odd numbers which are greater than 10. So we can combine the predicates like this using AND. Similarly, we can also use another method called OR. Of course, putting OR will OR operator, you know how it works. It is going to give us more data. So if we run this now, so here we will say we got of course these 3, but also more values. We got the odd numbers more than 10, so 11, 19, 23. But we also got combination of we also got an even and also the values which are less than 10. So it is OR, so it is acting weirdly in this scenario, but you can use OR as well. So let's go back to AND. So you can basically keep on adding or putting AND operator into multiple predicates, and you can basically simplify it, and you can get more complex results by just writing simple code. You can also try, let's say, an example like this. Uh, you have a array of names with some empty string also in the array. So remove all empty string. So you can basically also implement this scenario. So far what we have done is we have seen the predicate function interface, and we have seen all the test in its single abstract method test, and also we have seen the AND method, OR method, and negate method, which are the default methods. But it also has a static method which is called as the is equal method. So let's check how that works. So I will create another class called predicate example is equal. So let's use this, and of course it will be we need to write this as a main method class, And let's say I want to check if two names are same or not. So I will say string name is equal to, I will say John, and then I want to use predicate. So I will create a predicate of string, and then I will say name equality predicate. Give a useful name, and then what we will do is we will not take the help of this time. I could do this. I could basically say uh, like this. Let's say n, and then I can take a help of uh, n dot equals something I can say. But the problem here is we don't want to use that. We want to use the predicate static function is equal. So as soon as I write this, so I want to check if the name is, let's say, John or not. John. So what I will do now, I will simply go system.out.println. I will say name checker predicate equality dot, and here I will say test, and I want to I will pass the name field here. As soon as I do this, I will see, I will run this, and then it will be saying me that yes, it is equal. So we got a true. Let's say I will change this as John H. Now it will give us false. You see, this is false now. Great. So let's take another example for checking the equality. So let me create a class called stock. And here I will basically just keep few fields. I will say string, stock name, and I will say integer. For now, I will just keep integer price, stock price. And I will say integer stock quantity. These are the three things. Then I will keep a constructor, stock constructor, which will help me set the values. So I will say stock name, comma, stock price, comma, stock quantity. So I want to check the equality of the custom object, custom class object. Here it's stock. So I'll say name, this dot stock price is equal to stock price. This dot stock quantity is equal to stock quantity. So I have this. So let's override the toString and equals method here. So I will say public string toString, and I will just say direct override. Okay, and then here we will just say return. I will just say stock name. Name is, I will say plus this dot stock name, this dot name, sorry, name. Then I will say price is, I want to print this way basically. So I will say this dot stock price. Then I will say comma whatever way I want to print, I basically am writing that. So here I will say quantity is this dot stock quantity. Alright, great. So now we have this three. Now I will also override the equals method. So you know the toString and equals method are part of the object class. So we will override it. So I will say public boolean equals object and let's override it. So here what we will check is that if all the fields are equal, then only the object is equal. So first I will convert this one to a typecast this one to a stock type. So I will say stock is equal to stock and then I will convert this. So this will get typecasted. Okay, now I will say if the name is equals to the stock dot name, this and stock price is equal to let's say stock which is coming dot stock price and stock quantity is equal to stock dot stock quantity. If all this is true, only then it will this both return true. Return true. Only then the current object and the object that is coming are true. If all these are true, only then. Else we say return false. If any of them is not equal, then it will return false. So this is our stock class. Let me create another class which is let's say trading class. Say trading class. So here I will basically create a list of array list of stock equal to new array list. That is fine. I will say stocks now what I will do, let me create a static array list. So let's write public static void main and in here let me populate some data here. Stocks dot I will say add and I will say new stock and I will say the name is Apple, price is 500 and the quantity is 20. Similarly, I will say I'll add two more. Facebook stock price is let's say 400, quantity is 10. I would say Google third stock, I would say price is 560, quantity is let's say 22. So these are our static stocks. So now we will see how we can basically compare them. So now what we will do, very simply we will write a predicate to check the equality. So I will say predicate of this of on stock, because we want to check the equality of the stock. So stock equality, which stock is equal to, we will say predicate dot is equal. Let's say I wanted to check the stock of this company. Basically I wanted to check the stock of Facebook. So I will create a stock stock. I can bring it here also. So I will say here, I don't need this then. So I can say stock to search. So this is the stock which we want to search for. Okay, great. So now I will say stock to search is this one. I'll put this one. There's a typo. So I will say search. Copy this stock to search. Okay. Now what I will do, we will run a for loop for stock s in stock list, or what is that? Stocks, all the stocks. So we will get one by one all the stocks. So if now we will say stock equality predicate dot test and pass the stock, and then we will say system dot out dot println stock found, and we will print the stock. So it's going to print the whole stock because we have overridden the simple toString method. So basically we should print it should print the details of FB. So let's see what happened, what went wrong. Let's try to debug what is going on. So if I put a debugger here, and then I will put a debugger on this as well. So we'll see what will happen now. Debug. So it's going to come here in the loop. So first stock is this. Name is this. Okay. So it will go here and it will return false. Great. Second stock is FB. So it will come here. Stock name. Wait. What happened? This is FB. This is FB. Price is 400. Price is 400. Price is 10. Price is 10. Still it doesn't work. So I think we have to do a different equality check, because we are using the wrapper classes, so we can go for dot equals. So here we will, instead of this, we will say dot equals. If you take a primitive data type, then the normal equal to works, but this is primitive type, not the primitive type, but the wrapper type. So we have to use this. So now let's run. So now it says stock found, which is FB. Great. So this is how you can basically also check the equality of a custom object, which is here stock. So this is the power of the predicate, which is the default provided function interface.